All right, example 4, we've got a mixture of cosine and sine, which isn't very good for solving for theta. We want to get down to one trig function if we can. And normally when we've got something that looks like this, it kind of tells you you're probably going to want to factor this because we do have something squared, something not squared, plus something. So it looks like a quadratic trinomial if we could get it down to all the same term. And our goal here is to solve for theta and find all the theta values between negative 90, including negative 90, up to 270, not including 270. So all the answers between those that when you plug in that number, you get 0. So the first thing we'd want to do is change either cosine squared into sine or change sine into cosine. And it's much easier to change something squared than it is to change something that's not squared. We don't have very many properties where you can just change sine. But we do have a Pythagorean property that we could use to change cosine squared. So if you look at your properties, I've got this property that says, can't see it, that says cosine squared plus sine squared is 1. So if you subtract that sine squared to the other side, that would say cosine squared equals 1 minus sine squared. That's what we're going to change it into. We're going to change that into 1 minus sine squared. And then we still have this plus sine plus 1 equals 0. Well, now I have all the same type of function, and it's all sine theta. We can collect like terms. If we put those ones together, those make 2. And normally when we factor, we want to have the square term be positive. So I'm going to factor out a negative 1. Takes a negative out of all 3 terms. And we want to factor this. And so we got to figure out what makes sine squared. Well, that would be sine times sine. And I'm looking for numbers that multiply to make negative 2, but add up to negative 1 in the middle. So that would be negative 2 times positive 1. That makes negative 2, and negative 2 plus 1 makes negative 1 in the middle. And now that it's factored and it equals 0, we can set each factor equal to 0. So here I'm going to add 2 to the other side. I'm going to do inverse sine to get theta by itself. Just general solving. And then I'm going to look at my table and see where does sine equal 2. And if I look through here, sine never has 2 as an answer. So this leads to no solution. There's never going to be a time where sine equals 2. So there's no theta that gives you that. Well, we still have this one over here. Maybe this will give us an answer. So if I subtract 1 to the other side, I get negative 1. If I do inverse sine to the other side, I've got theta isolated now. So I want to look at my table and see where does sine equal negative 1. Sine's only negative 1 in one location, right here, and we're in degrees, so that'd be 270 degrees. We're going to make that a general solution by adding 360 in. So that's my only general solution here, and I want all the answers between negative 90 and 270. So the first answer I see is 270, but there are parentheses on it. So that means 270 should not be included in my list. If I add 360, it'll be way bigger than 270, so that won't help. If I subtract 360 from 270, that would give me negative 90. And negative 90 is included in this interval that they give you because of the bracket. So negative 90 is the only answer that we get for example 4.